All right, so yesterday we talked about, let's review really quick. So yesterday we started talking about absolute value and composition, right? We talked about what if you're composing a function and with absolute value, what does that mean, right? So what that means is that I'm taking the whole entire function and I'm plugging it into the absolute value, okay? And what does absolute value does? It eliminates all negative outputs, right? And so when we did that, all of our original function, notice here, it was a linear equation. And when we plugged into the system, all of its negative output, so all of the negative y values became positive, right? That's because we changed the whole expression. Does that make sense? So we changed the entire output. Same thing here. When we graphed this quadratic, we took all of its negative values and they became positive values, right?
Wait. Oh, okay.
Right?
I get another graph paper.
Yeah.
Let me try to
Okay.
table.
So I'm gonna go over the table. So someone asked, how is this working? Well, if you're looking here, all we had was our original value. So at our original values, we were starting at 0. We had -3. We had 1, -4, 2, -3, and then we were back at 0, right? So these were the only negative outputs that we had. Well, all in between, but point-wise, these are all of our negative outputs, right? And so we just took these values and made them into positives. Do we see that? Again, that's because we took the absolute value of the entire function, the entire output, right? All right, today, what we're going to be doing is we're going to be taking the absolute value of just the x and see how that changes our function, okay? We're only taking the absolute value of just the x. So, all right, we're going to create a new function. So let's do f of x equal, all right, someone give me a number.
4.
4. At 4x and another number.
20.
That's too big. That's too big. I need this one. I need a number under 5.
2.
3. All right. We'll do 4x minus 3. Okay. So we have f of x equals 4x minus 3. Are we able to graph that?
Yes.
Yes, we're able to graph this linear function. So we're going to go to -3. And my slope is 4. So I'm going to rise 4 and 1, 2, 3, 4 and run 1, right? Rise 4, 1, 2, 3, 4 and run 1. 1, 2, 3, 4 and run 1. Then I'm gonna fall and crawl. 1, 2, 3, 4, crawl 1. That's all I can do. And now I'm gonna draw the straightest line that you've ever seen.
I guess.
That's pretty straight.
There you go. Bam. All right.
Wait.
You should be able to do a linear graph without me,
I
like
know,
you-
I just didn't know.
right? That's
I guess.
that should be able to be done. So that's our f of x. Agreed? All right. Now, what did we let g of x equal yesterday? G of x was what throughout our notes? The absolute value of x, right? G of x is the absolute value of x. So our g of x is our absolute value. Now, what we've been doing is plugging the functions into g of x, right? Now we're going to compose f composed of g. And if I have f composed of g, that means that I'm plugging g of x into f of x.
So if it technically means like f times g.
It does not mean times, it means compose, which means I'm putting it into it.
Oh,
Yes.
compose.
Compose.
That's like a little circle, not a block.
Exactly. It's an open circle. It's not a closed circle. It's an open circle.
I mean, it's going inside.
It's going inside.
It's within.
Okay. So what is g of x? Well, g of x is the absolute value of x. Okay. So that means wherever x is, it now becomes 4 absolute value of x minus 3. So now this is what we're working with. Does that make sense?
Yes, ma'am.
Okay, so now we're working with the absolute value of 4x minus 3. So when we're looking at our table, so we're going to talk about this as a table. Looking at our original graph, what are the values we have? We have -1 and -7, right? This is in our f of x. Agreed? Yeah. And we have 0 and -3. Yeah. We have 1 and 1. Do we all know how to read a graph? You see where I'm coming from?
Oh, we're just plugging it in.
I'm just saying, what do we have already? We have 2 and 5, and we have 3 and 9.
Okay.
Okay, that's all I did. I made a table of what we have already graphed. So now, when we are looking to graph our new one, so now we're looking to graph f composed of absolute value of x.
Oh, I see that. And the only one that'd be different. is which two?
Just the first one, actually. Okay. So we're now focusing not on the 7, it's the absolute value of the x. It's the absolute value of the x. We're not touching these values. We're only focused on the x. So what is the absolute value of -1?
1.
1. And what do we get at 1?
1.
1. So this is 1.
We did this like 2 weeks ago.
Some of it, part of it.
I don't understand that.
When we talk about absolute values, plugging things in, yes. All right, 0. Well, is that going to change?
No.
No. So its value is going to stay the
Same.
same. Is 1 going to change? No. So its output's going to stay the same. Is 2 going to change? No. So its output's going to stay the same. Is this going to change? No. So its output's going to stay the same. So the points that I'm graphing is at -1, 1.
Okay, so do I graph that?
Wait, I don't understand. What am I plugging it in?
Absolute value of the x.
Oh, so the next one was played.
Exactly, because that's the difference.
Zero, negative.
We have the negative, like already like 0 is not negative. We're only. doing absolute
You're
value
taking the
of x.
absolute value of the x.
Oh.
Because the,
Oh, I understand now.
it doesn't matter what the y is,
-1, that was the only x value. That was negative.
okay?
Well, we get -3 from.
0, -3.
Cause like something could still be lined up to like the -3 on the x axis.
I understand
But it could
now.
still be positive.
I'm becoming
Exactly.
Smarter.
Okay, so the difference from yesterday and today, yesterday we were changing our output. Today we're changing our input. Does that make a difference? Yesterday was all about the output, the y. Today's all about the input, the x. Okay, so our x's are what's changing, not our y's. Okay. All right, so now that I have this, I now see that this is where my line is going to start, right? And then these values state the what? The same. So these values state the same. And just like all absolute values, they're going to mirror each other. So if I wanted to find -2, I would just plug -2 in. And what is the absolute value of -2?
2,
2. What is 4 times 2?
8.
What is 8 minus 3?
5.
So at -2, I'm now at 5.
Okay, that makes sense.
For absolute value of -2 minus 3.
So it's 7?
What is the absolute value of -2? 2.
Miss,
What
you
is
put-
4 times 2?
You put it at 7.
Oh, I did? My bad, y'all. It was me then. Let's blame my Dayquil. Yes. What were you talking about? I don't know what happened there.
Oh, yeah?
Nope, not at all.
Crazy.
It's super
It's
crazy.
doing its own thing?
Yeah, the computer did it. Okay, and then I can keep going, but this is where it's at. Okay, again, the straightest lines you've ever seen taking place. Okay, and so it makes sense that it ends up creating an absolute value because this is just an absolute value function. It's an absolute value with a value of 4 and a y-intercept of -3.
Oh. It's somewhat making sense.
Okay. So again, it depends on what we're changing. So you have to pay attention to what you're changing. Does that make sense?
Yes, ma'am.
Okay. So, now your assignment, this is a little half sheet. So let's look at the little half sheet. So you're composing with absolute value functions and you're given this graph. And no, it's not linear. No, it's not quadratic. It's actually, is this sine? Yeah, sinusoidal.
What?
It's a sine graph.
Oh.
That's all.
Don't worry. You'll worry about it later. No. Yeah, don't worry your pretty little brains. All right. So what you're going to do is you're going to use this graph. Notice here on the first one, it's our y values that are being changed, right? On this one, what is it? The x values. It's the absolute value of the whole function, the absolute value of just the x's, okay? This is your original. So you're looking at the original and just plugging in the values. On part B, you're gonna need 2 colors because you're gonna graph and compare, okay? So on part B, you're gonna graph your first one, your absolute value of f of x and the absolute value here, and then you're gonna compare them, okay?
Yes, ma'am.
So again, you're gonna need 2 colors or a pencil and a pen, something that just distinguish between the 2 graphs. Okay. Just reminding you guys, when you're graphing, I had someone earlier not understand the graphic, and I just want to make sure we're all on the same page. When you are graphing, if I'm graphing this, I'm still using the same. These are going to always be my x values. Does that make sense? My y values are changing, but these are going to always be my x values. I saw someone kind of going side by side. So like they graph these 2 together, then graph these 2 together, then graph these 2 together. Yeah. And I'm like, no. I just want to make sure your x value is going to be the same for each one of these columns. Does that make sense? So like, for example, to make sure we're all on the same page, if I'm at -4 on f of x, I'm going here, right? And what is the value of -4? 0, right? If I'm going to -3, right? So now I have my original and then I create everything from that, okay? As you finish your table, on the back of the door is the answer key for you to check yourself. Do not go to the answer key first, do your table, try it, and then go check yourself, okay? Got it? All right, get to work.
I did my.